My name is Lusjen Ismaili. I'm from Albania. I'm petroleum engineer. In this topic, I am with my colleague, with Ismaili, which is a petroleum engineer. Okay, our topic is about physical formulation and mathematical analysis of the production decline curve in calculation of the decline rate for oil fields. So our paper is shared in 4 rubrics. The first rubric is abstract, the study of fluid filtration in porous media, the different stages in which production passes during the exploitation of oil and gas bearing field, the mechanism in which field filtration occurs in porous spaces, as well as the pressure energy. In this case, the energy is about pressure, because every moving of fluid in the underground reservoirs based on pressure or energy contained in the fluid, which also determine the stage in which the underground reservoir of oil and gas has passed, are the main parameter in the application of many calculations in reservoir engineering. So in this paper, the decline analysis method is reflected specifically in the determination of the production decline rate by analyzing each formula that correspond to each of the type of decline, including exponential decline, harmonical decline, and hyperbolic decline. Every decline, as I say, exponential, harmonic, or hyperbolic, are shown based on IARF studies. The main objective of this paper is to present a link between the physical context and the mathematical analysis of the production decline curve during a certain time period of the exploitation of underground oil and gas reservoir, helping to determine the production decline rate. So the second rubric is introduction. Okay, in general, in the study of the mobility of fluids in porous media, a mathematical analysis is required depending on the condition in which the filtration process takes place, the type of fluid being filtered, and the geometry symmetry of the flow that is created. So I say the type of fluid because in the reservoir engineering we have 3 types of fluids for different studies. For the first type fluids, incompressible, slightly compressible, and compressible fluids, and this is the reason to have to take in consideration the type of fluids. In the case we do a study to the underground underground oil reservoirs. The use of the production decline curves analysis is a method which serves both for the calculation of oil and gas reserve in underground reservoirs, but also for the prediction of future productivity from this reservoir. So the most important point based on the decline curve analysis is prediction of the future productivity from these reservoirs. Based on this term, we can say the decline curve analysis is very important, because based on the different data we have from site, we can do analysis, and we can do the prediction of productivity of the reservoir in the future. Also, another important impact is on the evaluation and audit of the various investments that are made during the exploitation and production of oil field, or how to say, during the exploitation and production of oil field, we can say is a development plan for exploitation of oil field. Based on this physical treatment and mathematical analysis step by step for each decline, take into consideration exponential decline, harmonical decline, and the hyperbolic decline is important, not only in the mathematical verification for every formula taken into consideration, but on the other hand, based on the analysis of the decline, we can determine the decline rate. So the decline rate is very important parameter, because based on this parameter we can do everything about calculation of reserves in the oil or on gas reservoirs, etc., etc. So the third rubric is methodology, or how to say before, how to say above, based on the proposal of ARFs, the rate curve as a function of the time can be expressed mathematically by one of the equations of the hyperbolic family. So based on this, we come to the conclusion that each type of curve will have a different curvature depending on the different parameter between there. So based on this, the formula of decline rate is d equal minus d ln y divided t equal minus 1 divided q multiply dq divided dt. So the most important thing in this case is to say minus sign, because the decline rate with a positive value, this is the reason for placing the minus sign in the above expressions, since dq qe divided dqt have opposite signs. Based on this formula, d equal q here q exponential b, and to different calculation, but we can take in consideration coefficient b equals 0. In this case, we have exponential decline. We come to conclusion, which is d equal ln yi divide by t and divide t. So in this case, yi is initial production rate and while t is production rate at time t. So another method in this case is take into consideration 2 points, T1 Q1 and T2 Q2 on a straight line with a low analytic determination of on the value because. And on the other hand, based on two different calculations, we come into conclusion d equal ln y2 divide 1 here multiplied 1 divide to 1 minus t2. So the old formula above and this formula 6 and 7 are in the case of exponential decline, and for expression 6 and expression 7 express the formula of decline rate in the case we have exponential decline. So another case at the moment we take in consideration cumulative production NP. In this case, we can reach based on to different calculation. We can come to conclusion 8 and 9, which is a decline rate. It's another value of decline rate for exponential decline, which is d equal qi minus qt divided np. In this case, qi initial production rate at time t, and np is cumulative production. So all above formula mathematical analysis step by step to derive the final result for the decline rate by combining and replacing all the parameters that take part in them. It is possible to calculate the decline rate for exponential decline. So on the other hand, at the moment we can take in consideration harmonic decline. In this case, harmonic decline. In this case, the harmonic decline, the coefficient b is equal 1. So based on two different mathematical calculation for harmonic decline, we reach in conclusion expression 12 d di equal Q here NNY minus LNQ divided NP, cumulative production. All the above formula that express the calculation of the decline rate, both for the exponential decline and for the harmonic decline, have been calculated by mathematical analysis step by step. All the parameters that take part in them, the combination substitution of the physical concept of the relationship between layers. So another important thing for to say is for the calculation on the harmonic and exponential decline is the last quartz method. Is very important method. And the fourth rubric is conclusion. So based on this conclusion, I, together with my colleague, with Redian Ismaili, we reach in conclusion as following. Decline curve analyzer can be applied to almost any manufacturing operation hydrocarbon, which is applied both in technical assistance for the forecasting and future development of underground oil and gas reservoir. But also, in a forecast and economic analysis in the value investment that will be developing in the field, including here equipment facilities such as pipelines, plants, and training, or how to say above. In this case, in this point we are in the case of development plan for every oil field or gas field. All above formula that express the calculation of the decline rate both for the exponential decline and for the harmonical decline have been calculated by mathematical analysis step by step. All the parameters that take part in them, the combination, substitution of the physical concept of the relationship between these, which help us in the truth of the value of the decline rate during various application, but in the site and in the relevant software for the calculation and prediction of hydrocarbon reserve. This is all our paper. Thank you very much. Have a question, please?
Thank you for the presentation.
Thank
In
you
any
very
case,
much.
if you have any questions, please raise your hands.
Thank you very much.